Welcome to my second devlog. In this one we are going to talk about the grid system. Almost everything in the world interacts with it in some way. To make it efficient, I split the map in two imaginary grids, one big one and one small one. The large grid is divided into 10 by 10 cells. I use this as a spatial hash grid for nearby units. Instead of every unit checking the entire map to see what's around it, they only look at their immediate neighborhood. This keeps the lookup time slow and protects the performance. My small grid handles the exact data for individual cells. It's responsible for three main things: the blocked cells, so the game knows where units can and cannot walk and where I can build; the explored cells, to keep track of the fog of war and what the player has revealed, so we can't build outside the explored area; and the environment objects like trees or mushrooms. When the world generates, environment objects are placed into this small grid. Since they don't have a unique entity ID like a unit or a building, I block their respective cells using a dummy ID of -10. At the same time, the environment grid stores the object type, the specific multimesh it belongs to, and its multimesh index. Storing the multimesh data is really useful. For example, if a unit walks behind a tree, the game can instantly look up that specific index and make the leaves transparent, so the player doesn't lose sight of their unit. It also allows us to easily highlight resources when we need to. When a building is constructed, we block the entire area around it in the small grid. This prevents other structures from being built overlapping it, and it handles our pathfinding. For performance reasons, I don't use actual physics collision in the game. Instead, the grid handles it all. When a unit wants to move, it just does a quick lookup to see if its next target cell is blocked. If the grid says it's blocked, the unit can't walk there. It's incredibly lightweight and saves a massive amount of CPU overhead. When a unit is recruited, it registers itself to the large grid for nearby objects lookup, and it begins updating the small grid to mark cells as explored. As units walk over and cross cells boundaries, the game constantly monitors their position. The moment they cross over a line, we smoothly migrate them to the new cell in both the nearby grid units and the explored grid. When a unit dies or a building is destroyed, the game handles the cleanup by completely removing them from the grid system, unblocking the small grid ties and removing them from the nearby objects lookup, so everything updates instantly. And that's a simple overview of how the grid system works. If you have any questions or suggestions on how to improve it, I'd love to hear them in the comments. Thanks for watching, and I'll see you in the next devlog.